Hello, my name is Tu Lu. I am the Chief Product Officer at Cumulus, and welcome to my presentation, Data-Driven RMF, a data-driven approach to implementing the risk management framework. This is the agenda we're going to be covering today. I'm going to start with a quick overview of our company, who we are, what we do. I'm going to get into a quick description of traditional approaches to risk management, compliance management, and then I'll contrast that with a data-driven approach and how it can be streamlined. Then we'll talk about a high-level architecture of the solution we've built to implement this data-driven approach, and we'll talk about the two underlying data models that are basically the foundation of this solution. And we'll talk about some of the common data sources that need to be ingested to implement such a solution. And we'll go into a deep dive example using Windows security event logs and how that information can be used to help you streamline the assessment of the account management control from NIST 800-53. Then we'll wrap things up with how this could be more broadly applied to other controls, other standards, and provide some links to additional details on our blog for how our solution supports all steps of the RMF process. So Cumulus was founded about 8 years ago by an former executive at DHS, whose mission was focused on trying to revamp the government's policies for compliance and risk management to make them basically provide more operational security value. So he left DHS to found this company and create products that enable that mission. So we've got two products, Q Compliance and Q Audit, that are focused on compliance management, risk management, and auditing automation. We've got customers in both the public sector and commercial space, and our mission is basically, as it states there, focused on compliance automation to deliver operational security value. So when we talk about risk management, compliance management, this is probably what most people think of. A lot of very manual, labor-intensive processes, a lot of data calls, and just a lot of documentation. Right? So you're writing system security plans that are hundreds of pages long. You're writing implementation statements describing how you've implemented your controls. You're documenting the test procedures for how you've tested those controls. And all of this is just a very painful, labor-intensive process that's based on static snapshots of information you collect through data calls. And once you're done with all of this, it's often based on basically outdated information. And it really doesn't provide a whole lot of security value to really help you protect your systems. Now contrast this with a data-driven approach where you're using data that's automatically collected from your IT environment to streamline, automate, and inform decision-making to manage the cybersecurity risks with developing and operating your information systems. So rather than just reviewing implementation statements and taking a trust me approach, a data-driven approach uses the machine data that's collected from your systems, networks, and assets, for example, logs, configuration settings, events, transactions, and so forth, so that you can continuously monitor and verify that your controls are providing the required levels of protection. And for those of you who aren't familiar with this diagram, these are the 6 steps of the risk management framework from NIST Special Publication 800-37. So a very simple yet effective process for implementing risk management. And throughout this talk, we'll basically be talking about how a data-driven approach can support all of these steps of the risk management framework to streamline and provide actual security value with this approach. So this is the high-level architecture of the solution we built for a data-driven approach to the risk management framework. So it's built as a Splunk solution. So we've basically used Splunk as a full stack development platform to implement a custom application. So at the bottom there, you see in the light gray box, a lot of different data sources, right? So our mantra at our company is basically that all machine data is compliance relevant. And if you look at the breadth of what's covered by the NIST security controls, you'll quickly see why, right? There's so many different security domains and use cases that is covered by those, that there's just so many data sources that could be collected to help you assess against those controls. So that's basically what our platform does, right? It uses Splunk to collect that data. We normalize it against some data models we've developed to basically have a canonicalized, normalized data model from which we then develop the analytics based on the specific requirements of what the NIST security controls are asking for. And then those analytics are presented through a set of custom dashboards for each of the NIST security controls, as well as different dashboards to support the different steps of the risk management framework. So throughout today's talk, we'll mostly be focusing on the Q compliance application. That's our flagship application for risk management, compliance management. So behind the scenes for how all of this works. So step one, getting data into Splunk. Right? So as you're implementing your security controls, the different tools, platforms, and systems that you're using to implement those controls, we also pull the data streams from those into Splunk. Right? One of the main reason we built on Splunk is because it's such a popular platform that there are a lot of out-of-the-box connectors. They call them TAs, technical add-ons, right, to ingest data from the different security tools and systems into Splunk. So it makes it very easy. Right? So that's step one, is just getting that data into Splunk. Step two is apply Q syntax. Right? So what that means is you're taking the data that you're ingesting and you're basically mapping it to our data model, our compliance information model. That's what we call the QSIM, the Cumulative Compliance Information Model. So that takes that data, normalizes it against a common format, and we use that common format to then develop the Q analytics, right? A set of queries based on the specific requirements of the security controls, along with different automation actions, alerts, and so forth that help you take action on the data that's pulled in, right? So automatically passing or failing controls, automatically creating POAMs, plan of actions and milestones, automatically granting authorizations to operate, and so forth. And then in step four, leveraging the Q visuals, right? So the analytics are presented in a user-friendly way in a set of dashboards for the different security controls, so that auditors and assessors can then come in and look at that evidence to assess if your controls are operating and implemented effectively. Right? So rather than relying on outdated manual data calls, they're now coming into dashboards and seeing in near real time the compliance posture of each of those controls. So as I mentioned, there are two data models that are the foundation for implementing this solution. The first one is the compliance data model. So this data model basically represents the objects that need to be protected, what needs to be protected, and the characteristics that define the level of protection that's required. And so basically this captures the information that allows you to baseline your system, categorize your system from step one of the RMF process. In addition to that, it allows you to define your authorization boundary. So, i.e., what individual hardware and software assets define or comprise your system. And it captures the characteristics of that are important from a security and privacy perspective. And all of this is implemented as a relational data model in Splunk's KV store, which behind the scenes is just MongoDB. Then the second data model that's required as part of our solution is the control analytics data model. So this is a high performance data model for control technical evidence. So these are entities that model the security domains of the 800-53 controls. So they capture the data that's required to assess and monitor if controls are implemented and operating effectively. And all of these elements are linked with the risk management subjects from the previous data model to provide that technical evidence for those systems and those controls. And this data model is implemented as an extension of Splunk's Common Information Model. So what we've done is we've taken Splunk's Common Information Model and we've extended that by adding additional objects and fields that are needed to support the different security controls and compliance use cases. And this slide, it's a pretty busy slide, but it gives you a broad view of the different NIST control families from 800-53 and examples of different technical data sources that you could be pulling in data from to help you assess and monitor the controls from that control family. So as I mentioned earlier, our mantra is that all machine data is compliance relevant, and you can see more specific examples of which different types of tools, operating systems, and platforms are needed to support the different controls from those families within the NIST catalog. So now that we're done with a high-level overview of our solution, let's get into a deep dive example. So we're going to be looking at how we can use the Windows security event logs to help us assess the account management control from NIST 800-53. So this is a specific control from NIST AC2 for account management, and more specifically automated audit actions for account management. So the specific requirement for this from NIST is the information system automatically audits account creation, modification, enabling, disabling, and removal actions, and notifies organization-defined personnel or roles. So now we'll look at how we can pull in information from Windows security event logs to audit all of these actions. So there's basically three groups of information that are needed. So first, we want to determine that an account was created. So to do that, we look for logs with the event code 4720. So that's the specific Windows security event code that tells us that an account was created. Second, we want to look for the keywords audit success. You could also have values such as audit failure, but audit success here means that an account was successfully created. Third, we'll want to pull the message element. So this is just a user-friendly description of the specific action that was performed. A user account was created. So that's the first group of information we need. Second group of information that's important is who created the account. So to do that, we look at the subject grouping of elements there. So from the subject grouping of elements, we'll want to pull the security ID and the account name. So that basically tells us which user performed that action. So you can determine, for example, if that user is indeed an authorized user to be performing account management actions. Then the third group of information that's important is what account was created. So to do that, we look at the new account section of that Windows event log message. And again, we're pulling the security ID and the account name to see specifically which account was created. So those are the three groups of elements of data we need from the Windows security event logs to audit and monitor this account management control. So then what do we do with this information? So basically we need to extract that event and map it to our data models. So it's a three-step process to do that. So first we define an event type in Splunk. So if you're not familiar with Splunk event types, you can think of them as basically a named query, right? So we're creating a query called QUserCreatedWindows. That basically is saying, let's look for events that are user account creation events from Windows. So we're searching against the index equals Windows repository. So that's basically which repository in Splunk we want to look against for Windows event logs. And then we're specifying source equals Win event log security. So there are different types of Windows event logs, for example, application and security logs, system logs. So in this case, we want specifically the security logs. So that's why we specify that in the query. And then as we mentioned earlier, 4720 for the event code specifies that an account was created. So we put that in the named query. So this is the basic event type that tells us that there was an account creation event within Windows. Step 2, we need to now tag that event type with the appropriate tags that allow us to map it to this data model, Cumulus Account Management. All right, so the way data models work in Splunk basically is you define what tags need to be applied to your data to map it to your data model. So that's basically what we're doing in step 2. So we've created that event type, i.e. that named query for user created Windows, and then we apply the 2 tags that are needed to map it to our Cumulus Account Management data model. So if you look at the little diagram here, Cumulus Account Management, in the constraints, you'll see that it needs to have the tag equals Q underscore account management. Also, there's a child object called created. You can't see it in the screenshot, it's cut off, but for that child object, you also need an additional tag called created. So that's basically what we're doing in step 2. We're applying these 2 tags to this event type to map it to the data model. So Q account management and created. And then in step 3, once we've done that, those events will now be mapped to this data model. And we can develop queries against this normalized data model. And you can see example in this little table here of what that looks like. So that's probably the hardest step in this whole process is figuring out the right event types to create and then doing the different operations to map it to the data model. So once you've got that, then you can start developing queries to present that data in any way you want. So in our solution, as I mentioned earlier, we have dashboards for all of the different controls from the NIST catalog. So in this example here, we're seeing the dashboard for AC24, Account Management Automated Audit Actions. And we've got 2 high-level charts, number 1 and number 2. So number 1 is showing account management actions over time. And number 2 is showing account management actions grouped by statuses over time. So whether each account management action was successfully completed or whether it was a failed operation. So let's look at the queries for how we develop each of these charts here. So number 1, this is the query corresponding to this chart here, account management activity by action. So we're basically wanting to see the account management actions that were performed over time grouped by those actions, right? So for those of you who have built OLAP, online analytical processing type applications with SQL databases, the syntax might look a little familiar, right? So this is the Splunk pivot syntax for writing queries. So basically it allows you to take that data and slice it and dice it across different dimensions you want to look at it from. So in this case, in the first chart, we want to see account management actions over time, and we want to see it by the different actions that were performed. Right? So that's basically what this query does. So we're working against this object here, queue account management, and then the specific data set is the account management data set. So we're doing a count of those events, and then we're splitting by time, because that's one of the dimensions we want to view things at, and then we're splitting by action. That's the second dimension we want to see. So with that query, we're able to see this chart here where we can see counts of the different account management actions, and they're grouped by the different actions that are performed, and you see counts of them over time. So then for number two, the chart in number two, we want to see, rather than splitting it out by the actions, we want to split it out by the statuses, right? And again, we still want to see it by time. So we're doing still a split row on time, but then instead of splitting on the action, in this case, we're splitting on status. So we can see counts of which ones have failed and which ones were successful. So that's an example of how you can pull in all of that data from the Windows event logs, map it to the data models, and then write specific queries that help you provide that evidence for auditors and assessors to validate that those controls are operating effectively. So then, if you remember, the final requirement of that control is to notify organization-defined personnel or roles, right? So we want to, in this case, provide more details of specifically what happened, right? So we want to see the time that the account management was performed, right? So we do a latest on the time to get the latest time that action was performed. We want to see the specific action that was performed, right? So whether it was created, enabled, modified, or suspended, and then we want to see what the account was that was created, right? So we do a split row on that. And then finally, we want to see who performed that action, right? So the source user or the account management, the account manager. So we do a split row of that. So all of that, this query here produces this table that you see at the bottom of the slide there. And what we can do with that is then create an alert action that is scheduled to run as often as you need to, based on how often account management activity is performed in your environment. And then you can set up an alert for that. And every time it detects these events, you can then send an email to the different personnel or roles within your organization to notify them that, hey, there was some account management action that was performed. You have the details of it, and then they can review and verify that. So that's basically the final step of meeting that control requirement. So to wrap things up, so we showed you how to do that for one control from NIST, right? AC24. So basically, it's rinse and repeat for all of the other controls across all the other control families from NIST. So obviously, there are a lot of controls within NIST, so it's a pretty labor-intensive process, but you're only doing this once, right? You build this once, and this can be applied to all your systems within the organization, and you're working off real-time data that's automatically collected rather than doing manual data calls, working off snapshots that are weeks or months old, right? So furthermore, what you can then do with that now is the subsequent steps in RMF, right? So what we've just talked about is basically the assessment step. So once you've done that, then you can use that information to go support step 5, right? Ongoing authorization. Now that you can automatically monitor these controls using real-time data, you can set up additional automations where, if a certain threshold of those controls pass, then you can automatically grant that system an authorization to operate on your production networks. And then finally, or more importantly perhaps, is continuous monitoring, step 6, right? So once that system has gone into production, you still need to continuously monitor those controls to make sure they're continuing to operate effectively, right? As these systems evolve, as the adversaries and threats evolve. And now you're basically implicitly set up to do that, right? Because you're automatically collecting all of that data from your systems, from your networks, and it's continuously feeding all of these dashboards continuously feeding all of those alerts. And that's what really enables you to do true continuous monitoring. And finally, we know a couple months ago, NIST 800-53 Rev 5 just came out. So we're working on some updates to support the additional controls and changes within that. And then this approach can be applied to other standards and frameworks as well. Right? So we've got a lot of public sector customers, so that's why we built around NIST. But the same approach could be applied to other standards such as HIPAA, PCI, CIS, Top 20, and so forth. So that was a lot to cover in about 25 minutes. We've got a lot more details on our website. We recently published a blog series on data-driven RMF. Here's the link to it. Please go check it out, and you'll see more details on how we support each step of that RMF process with this data-driven approach. And that's it. Thank you very much.
Welcome to the live Q&A section. We have a number of questions, so we can get right to them. First one for you, I'd like to know, what challenges have you encountered with organizations trying to adopt this data-driven approach to risk management framework?
Yeah, that's a great question. It really runs the whole gamut across people, process, and technology, right? Especially with folks in the compliance space. They have to very strictly follow a given process or standard. So a lot of times we go into large organizations or agencies where they've got pretty well-defined SOPs for doing these things, and then to come in with a new tool that says, hey, here's a new way of assessing your controls for correctness, and where it deviates from existing policy that can cause some heartburn for folks. So that's certainly one of the challenges on the people and process side. Some of the other challenges we encounter are, especially for government customers, a lot of times mandated to report into existing systems that are sort of the authoritative sources for the risk information. And so then we come in with another tool that has some potentially overlapping capabilities, right? So then a lot of times we have to build integration into these existing legacy tools so that end users aren't basically double entering data into a couple different systems. So there's challenges on that side. And then there's challenges with just data sources, especially with the standards we work with, the NIST 800-53 control standards, which are pretty broad and far-reaching. A lot of times, not all the customers have the data sources that we can integrate into the system to allow them to monitor those controls. So just the breadth of the controls and the supporting data sources, it's difficult to get that complete coverage.
Thank you for that too. We'll move on to the next question, asking any recommendations or preferences in terms of types of data for risk management?
Yeah, a lot of that depends on what controls are critical and important to that organization. We'll typically recommend what are your most sort of security critical or relevant controls, the ones that are kind of most volatile, because one of the main things we're trying to get at here is to reduce the amount of time between when you're collecting that information versus when it's assessed. So controls where there's a lot of activity, it's pretty dynamic, pretty volatile. We recommend kind of starting with those first, and then what data sources basically support those controls, right? So that's kind of one approach we take from a control-driven approach. Another approach is just looking at sort of what will give you the biggest bang for the buck. What data sources will give you the most coverage? And if we take that approach, then it's looking at sort of your broader tools and platforms or operating systems. You're going to get pretty good coverage from pulling in operating system data. And then whereas if you're looking at sort of more purpose-built tools and data sources, then you're not going to get as much coverage in terms of what controls you can monitor and automate from those. But you might be able to go a little deeper into the type of insight you can get into specific controls with those tools. So a lot of times it really depends on what controls are they trying to get up and running first. But we'll recommend, hey, look at the broader tools to get most coverage first.
Right. I know we're at 2:30, but I'd like to squeeze in one more question before we turn it over for Josh for the closeout, if you don't mind. We get a question from Discord asking, do you provide professional services to accelerate the ramp up in configuration period to get beyond the access phase of RMF?
Yeah, we typically do provide professional services just to get the system initially installed and configured and get some of the initial data sources onboarded and integrated with the system. And then it depends after that, how much expertise they have in-house for how much more professional services they need versus can they take on the rest of the adoption by themselves.
Great. Tu, thank you very much for sharing your expertise. We know you're going to hopefully hop over to Discord and check out the questions there. But like I said, lots more in the queue. But thank you for your participation.
All right. Thank you.